Okay, so here we will solve some interesting numericals. The first one is here. An isolated hydrogen atom emits a photon of 10.2 electron volts. We need to determine the momentum of photon and calculate the recoil momentum of the atom, find the kinetic energy of the recoil, and the mass of the proton is given. So visual inspection of this numerical, it's very evident from the basics of mechanics that the momentum of the photon, that is the photon as it gets ejected out of the atom, its momentum must be equal and opposite to the recoil momentum of the atom. So if you find the momentum of the photon, then that must be equal and opposite to the momentum of the atom. So primarily finding the momentum of the photon becomes predominant. It is more important here. And later on we need to, from the momentum, we can calculate the kinetic energy of the atom. Because as we know, the momentum P is equal to mv, or the kinetic energy K is equal to half mv square. So that becomes P square by 2m. So kinetic energy will be equal to P square by 2m. So from the first two sub problems, we will get the value of P, and then substituting it, say P square by 2m, the mass of the proton is given. So we will be able to find the kinetic energy. Now the question is to find the kinetic energy of find the momentum of the photon. Very simple. So as we know that a photon, as you know, the photon, okay, the energy of the photon E is equal to mc square, and this can be written as P square by C. This can be written as P square by C, or we can write it as mc into C, or the momentum P is equal to E by C. So here in this numerical, the photon energy is given as 10.2 electron volts. So 10.2 electron volts divided by C, 3 into 10 to the power of 8. But we should note that when we are using this formulation, the energy has to be expressed in terms of joules. So therefore, we will multiply it by 1.6 into 10 to the power of minus 9. So I suppose all of you are getting it. And divide by this, so we will get the momentum of the photon. So if the momentum of the photon, is P bar, then the momentum of the atom, if I am representing like this, then this will be equal to minus P bar. So calculating this, we will get the value, substituting this value, we get this. And the next thing is, we need to get the kinetic energy of the atom which has recoiled. So the kinetic energy of the coil which has recoiled, well, it's going to be K is equal to half mv square, and we can write it as P square by 2m. So from this data we would have got P square, substitute this, and this becomes mp, substitute the value of mp, so we will get the kinetic energy. That's how this problem can be solved. Very simple. And as I keep reminding all of you that in the first year PUC mechanics, as I kept on telling you that when we learn second year physics, we will be using a lot of first year mechanics, and therefore the first year mechanics will also get progressively, you will learn it more and more. The conceptual clarities will improve because we will be making use of them in solving many of the numericals here. I suppose all of you got this, right? Okay. Fine. So we'll move on to the next problem. Okay, friends, if you have any questions, you can ask. We'll move on to the next problem. Okay. The next numerical we'll choose would be this, and just have a look at it. So you have a hydrogen-like atom, but of atomic number Z, and the lone electron is already excited and it is at position 2n. So the data given is it can emit a maximum energy of photon of 204 electron volts. So that means if the electron jumps from the 2nth orbit to its ground state, n is equal to 1, then it is going to emit energy of 204 electron volts in the form of photon. And the second data that they have given us is it makes a transition to quantum state n, that is from 2n to n, and in the process a photon of energy 40.8 electron volt is emitted. This is the second data that is given. And then we are asked to find out n, z and the ground state energy level em, and also to calculate the minimum energy in electron volts that can be emitted by the atom during de-excitation. So here minimum energy means, see, the photon which is at the 2nth level, it can come down to 2n minus 1, 2n minus 2 and so on and so forth till it reaches the ground level. So it can come down from the highest energy state, in this case it is 2n, to the lowest. But they have asked minimum energy. So minimum energy, that means it is going to de-excite and come from 2n to 2n minus 1. That's all. Okay, so it is quite a simple problem, and I think we should be able to solve it. So anyway, I'll give you 1 minute. All of you think about it and see if you can handle it. Alright, so here we go, starting this problem. So we have the 2n state, and then we have the n state, and then we have a state where n is equal to 1. And then we have the state 2n minus 1 state. So the data that is given is the electron which is here, it jumps down to this. Then the energy that is emitted is given as 204. So the energy that is emitted here is 204 electron volts. And if it transits from this level to this level, then the energy that is emitted here, okay, will be how much? 40.8 electron volts. So this will be 40.8 electron volts. And that's it. That's the data that they have given. And now we have to find out the following values: Z, N, two predominant values that we have to find out. N, Z, and the ground state energy level. That is, we have to find the energy level of this E state. That is the problem. So the problem is quite simple. So we just have to use the basic equation here, that is delta E is equal to 13.6 into Z square upon 1 upon N1 square minus 1 upon N2 square. This formulation we have to use. So in the first instance, it is 204, okay, is equal to 13.6 into Z square into 1 upon, in the first case, it is n is equal to 1, so it is 1 square minus 2n whole square. Okay, and the second equation is, we will use the same equation but the slightly different condition. So again, it is going to be 13.6 into z square, and in this case, it is going to be 1 upon n square minus 1 upon 2n square. Okay, so by inspection, if we divide the one of the equations one by the other, then we can solve it for n. So from this, we will be able to determine n, and once we know n, substitute the value of n in one of these two equations. Say call this an equation number 1 and call this an equation number 2. Substitute this in one of these two equations, and then we will be able to determine the value of z. Okay, so that it is. And then they are asking us to find out the energy level at the of the ground state, for which it's quite simple. Once we know the value of z, then this energy level will simply be 13.6 into z square. Okay, so we need to plug in that value and get the value even. And since all these three are found out and n is known, so again we will use the same equation, delta E. So to find out this energy is what we want to find out, and here again it's going to be 13.6 into z square, the z that we have found out, but here it is going to be 2n minus 1 whole square minus 1 upon 2n whole square. Okay, so we will be able to determine the minimum energy level all in electron volts. Well, I think it's quite clear how these two problems are solved. Any questions? I hope it is all clear. Okay, fine. Thank you.